Okay, well, thank you so much. And first of all, the pleasure is mine to be here. Like I always find amazing how people get to know networks. There's a point in which you realize in your life that everything around you is networks, and you are in the path to discover that amazing perspective of what is around you, how you interact with people, how things affect you. And we are not living alone, actually, but we probably know that. And everything that happens in our life is actually happening within a network. So it's a pleasure for me to be here to share with you today a little bit of what we are doing, and especially we are going to talk about a special context, which is geographical, which is cities. And I'm going to try to show you today that cities are networks. There's many things that are happening in the city which are related to, or that can be described as a network, which nodes can be transportation, can be places, can be people, can be policies, can be institutions, etc. And links are relationships between them by how people move, how people interact, how people communicate, etc. So as Alejandro was saying, I'm the director of the Social Urban Network Lab. We're basically in the Network Science Institute. So you probably have come today to a number of papers that talk about preferential attachment. So for example, just so you know, Laszlo Barabasi is sitting next to me in the Network Science Institute. This is where I'm coming from, and other people like, for example, David Lazar or Alessandro Espignani. This is the Network Science Institute. We are about 80 people working on the science of networks. And this year we are organizing actually the Network Science Conference, the International Conference in Network Science in Boston. So all of you are invited to join us in June. There's the UEFA World Cup also happening in Boston. So if you come for the soccer, stay and you can join us for the networks. All right. So I'm going to talk about today about networks in cities. So let me start about why we should care about cities. Cities are actually very important, as you probably know. Cities are becoming more and more important today. Around 60%, 58, 60% of the people in the world lives in cities. Cities are becoming the place not only where things are happening, but also where people are moving into. I don't know if you know, for example, cities like the United States, the cities are more or less steady in population. But in other countries like China, for example, Nigeria, Lagos doubled the population. Lagos, you know, Lagos is the big city. Lagos doubled the population in the last 10 years. They doubled the population of a city in the last 10 years. So the cities are becoming more important. So one of the research questions in cities is whether we can build what we call digital twins. So you probably have heard about this concept, digital twins. The concept of digital twins means that we build a synthetic in silico model of how things work. This idea is borrowed from biology, in which instead of trying vaccines, for example, in people, or trying new drugs in people, you develop digital twins, which are models of how, for example, cells work or how the body works. It's a digital twin. And the idea is that you can use this digital twin to obviously understand what happened before, understand what is happening right now, and also to be more prescriptive about what is happening in the future. Okay, the problem in cities is that to build a digital twin, you have to understand that there are many things happening in the city which are interconnected. And this is my first network. This is very simple, only 3 nodes and 6 links. But it's basically that you want to understand the cities, you have to understand, first of all, the urban environment. The urban environment is very important, it's where things are. Like, for example, the Universidad Pontificia is here, but next to you have a neighborhood which is, low-income neighborhood, and more or less you have, transportation infrastructure which is getting back to you, etc. This is the urban environment. And there has been a lot of people trying to understand what is the impact of urban environment in what we call societal outcomes. For example, transportation is good for you because you can access things, for example, like different types of jobs, or for example, health facilities, etc. So there has been a lot of people trying to understand what is the link between urban environment and this one. But our research, and actually I'm going to show you later a little bit of what we are doing, shows that there is a piece in between the urban environment and societal outcomes. It's not enough to understand what things are in the city to understand how people is going to behave. For example, if you want to understand disaster resilience or economic growth or health outcomes, for example, during the pandemic, you cannot only investigate, for example, where health centers are. You need to understand how people move in the city, how people communicate, how people encounter, etc., in order to make the link between urban environment and societal outcomes. So my whole research, and this is like one slide about my whole research, is about this piece. How behaviors of people create these networks that help us understand how we go from urban environment to societal outcomes. Okay? This is my whole research. Okay. Let me show you that the city is really a network. I mean, there are many networks in the city. So, for example, there has been a lot of people working in what is called the road network. The road network is that every node is an intersection. It could be, think about two streets crossing each other, there's an intersection, and then the links between the nodes are the segments of the road that connect intersections. Or it could be, for example, the subway. Every node is a station, and the link between the nodes is basically a train that connects. Sorry. So this is what is called infrastructure networks. There are many of them. For example, the other one is the power, the utilities network. How, for example, electricity goes from one place to another. For example, waste management, how a waste is collected in the city is also a network because it's collected by garbage collectors, companies that move the waste from one place to another. Delivery is another network in which you have the centers where your delivery guy is picking up the food and delivering to you. This is another network. This is what is called the infrastructure network, and it's very well understood. Well, I'll come back to this one because this is a special network. You have seen a lot of social networks today. This is not social, or is not driven mainly by social say processes. It's driven mostly by infrastructure processes. Typically, there are costs. I mean, you cannot put a road everywhere, or you cannot put a pipe, for example, to transport water everywhere. So this is driven mostly by cost or by, for example, limitations. Like you cannot put a pipe, for example, through a mountain because it's very expensive. Okay. Okay, there are many other networks, like for example, this is communication networks in cities. There has been a lot of people talking about that. This is the social connectivity index. I don't know if you know this data set. This is a very nice data set that tells you what is the fraction of friendships between zip codes in the United States. So you can have this is basically the Boston area. So this is Boston, this is the city of Boston, and this is the Boston metropolitan area. And each of the nodes here is a zip code, and the links between the zip codes are what is the probability that two people in those zip codes are friends in Facebook. This is a public data set that Facebook publishes in 2019, and it has been widely used because it gives you an idea how areas in cities are connected. You can immediately see that there's something funny going on here. This is the Boston metropolitan area. So this is very, I mean, you know, the cities in the United States are the city center. Then you have the suburbs in which everybody has a car, a nice garden, etc. And then you have the peri-urban, let's say, parts of the city which are very rural. Okay, so you can see, for example, that the density of links within the rural areas is huge. Okay, but in the city center is very subtle. So you can see that even the city promotes or not connections between people. There's another paper, by the way. You don't have to write this down because everything is going to be in the slides. I'm going to share it with you the slides later. There's another nice paper about what is the influence of cities in creating these connections between people. Okay. Of course, there's another network, which is the one that I'm going to talk about today, which is mobility, which is how people move from one area to another. So, for example, think about commuting early in the morning. Everybody that takes the bus from going from downtown, sorry, I don't remember the names of downtown here, downtown to Pontificia. This is a flow of people that tells you how many people go from the city center to Pontificia every day. And then there's the one that from Pontificia to another place, etc. So you have the nodes are areas or places in the city, and the links are how many people go from that area to that one. This has been hugely important in the last 5 years for this reason, COVID-19. Because the way the viruses spread in cities are through this mobility network. Because, for example, COVID requires a human to transport the virus, okay? So investigating these mobility networks, we can investigate what are the places where most of the people go and what more infections could happen, okay? So this, actually I've been working also in the COVID, but I'm not going to talk about today about COVID. But this mobility network is very important, not only to understand viruses, but also, for example, things like transportation. This is, every city has what is called the origin-destination matrices that they use to predict traffic. The origin-destination matrices is typically a survey, or it comes off, for example, from what is called the transport card. It's called BIP here, the BIP in the subway. This is where people get into the subway and where people get off of the subway. This is what is called origin-destination matrices. All right, so you can see there are many networks in the city, and most of them are driven by people's behaviors. This is the one that I want to talk about today, which is more or less when people move around, they are creating networks in the city which are important for different processes. We're going to talk today about about many different things, but one of the things that I'm going to talk today is about segregation, and I'm also going to talk about business growth. All right. Let me show you also that cities, the networks that we have in cities are special. And not only they are special, as I was telling you, because, for example, with their own network, because there's constraints to build them up. There's also one important thing is that distance matters. You probably have worked already with some networks that have a geographical component. We were talking yesterday, I know we were talking, the wetlands, right? We were talking about humedales. The networks about the people working in humedales. And there are people that are in different places in the country, and distance matters. You will see that the probability that two people which are, 20 kilometers away of forming a tie is much smaller than if they are only 5 kilometers away. 70% of your friends live 15 kilometers away from you. Okay? That means that most of your friends are local. So spatial networks are different because distance matters. You don't have links, like go from one point in Alaska to Australia, although maybe probably you have friends in Australia, in Alaska, probably. Yeah, but they don't go. They have, there's a possibility of doing that, but the probability is very small. And because distance matters, they're different. Spatial networks are a little bit different. The first thing is that the decreased distributions are not typically heavy tail. So you don't have a node that has millions of connections. This is impossible. Think about the road network. There cannot be an intersection that have millions of roads coming to the intersection. At most, there could be 5, 6 at most. More than 6 is not really a thing in road networks. So because of that, the degree of a node in these city networks is very, very bounded from above. Okay. The other one is that typically the clustering coefficient is usually high. Okay. So you have a node that is connected to so you have, for example, think about road networks. You have a node which is an intersection which is connected with another intersection. There are chances that there's another road, another intersection which is connected to the three of them. All right. So typically clustering coefficient is usually high, pretty much like social networks. Clustering is but for other reasons. Spatial networks is different. It's not for the reasons that you find in social networks that clustering is high. Clustering in social networks is high because you want to be friends with the friends of your friends, right? So you have this triadic cluster. But here is totally different. The other thing is that because you are almost connected to your neighbors, to the live next door, the shortest path, I don't know if you have already talked about the shortest path, which is how many hops you have to navigate in a network to get from one node to another. This is typically long. Okay, this is typically long. Once again, think about the road networks. How do you go from one place to another one? Going through many segments. Okay, so you have to navigate the city in this two-dimensional space. And because we are living in a two-dimensional space, typically the shortest path does not is actually very long. Okay, and so we are not typically in a spatial network. We are not living in a small world. Okay, typically. And the final thing is the centrality is not related typically to node degree. And this is actually, I'm showing you, for example, here, these are the roads in the city of Boston. This is the city center. This is basically where, this is very old, Boston, it has this old city, it's an old part of the city, which has very informal, let's say, streets, etc., or not informal design, and this is a very more modern one. And then you can see that centrality is mostly in a low-income area, which is not the most central place, say, central in the sense of geography and central in the place of activity. And the reason is because centrality is not typically related to degree in these networks, because we have the spatial structure. So what is in the middle is actually what is geographically in the middle. Okay, this is what we said. All right. So I hope I can convince you that the spatial networks are all over the place in the city, but also that the spatial networks are a little bit different from what you typically see in social context. So if you think about communication between humans, you think about, for example, what is the social network within an organization, or what is the social network, for example, in social media, which do not have a spatial context, although most of your friends probably are living nearby. Those are different from this one. All right. So I'm going to talk all today, and then I'm going to move a little bit of what we are doing in our group. I'm going to talk about specific networks in the city that come from people's activities. So how we move around in the city, how we shop, how we get on transportation, etc., creates those networks. Okay. And the first question is what I mean by human mobility. Esteban, tell me, what do you mean about what is human mobility? And I'm going to tell you exactly what is the data coming from, so you understand what I mean by human mobility, instead of talking about human mobility. The data comes from this guy, that all of you have in your pockets. Everybody carries around 1 or 2. I mean, and there are, in the United States, there are 1.2 mobile phones per person. Okay, so that means that some people is carrying my other one. I don't know how to do it. Okay, and this actually, it has changed dramatically how we understand mobility in the cities, because now we have this device that can have very different sensors that tell us about how we move, how we communicate, how we interact, how we consume data, etc. The mobile phone has been this fighting arena in which a lot of companies are trying to get the most of you, most data from you. Okay, that you have social media applications, you have the operating system, iOS, Android, etc. You have many parties which are interested in getting as much data possible from you. The first one is your mobile phone operator. I don't know if you have Movistar, for example, here as mobile phone operator, or Vodafone, or whoever is here. They typically have your calls, and this is called call detailed record or extended detailed record, which means that you also consume data. Your telco operator provides you data. Every time you do that, every time you pick up your phone and you have the weather application on your screen, it will show you the temperature and what is the prediction for today. Every time you do this, you are connecting to the antenna. You know how many times you pick up your phone every day on average? Have you measured this? Well, in the United States, we typically pick up our phone every day 200 times, okay? On average. So that means that 200 times per day, if your mobile phone is connecting to the antenna, your telco operator knows who you are. They know where you are, okay? Because you have to connect to antenna, download the data, etc. Sometimes you are placing a call. This is actually very interesting because my kid, for example, I have a hamster, and they don't know that there is an application in the mobile phone to make calls. You remember there was an application to make calls, right? And people don't make calls anywhere. But anyway, you are consuming data, and because you are consuming data, you get data from the phone. This data is very frequent, so that means that, typically it's bounded by half an hour. Most people are making a call or getting data every half an hour. But the other interesting part is that the spatial resolution of this data is about 100 meters to 1 kilometer. Because typically the company knows that you are in an antenna. You are consuming data from a tower. Okay? And that tower is serving an area. And that area typically is 100 meters in the city center because there's a lot of people, or it could be kilometers in the countryside, which, I don't know, there's not many people. Okay? So that's great. It has been used for transportation, for example, like to get in the flows of people. I know, for example, that Telefonica and another I have actually a collaborator that has been using Telefonica data, Leo Ferrez, which is in Universidad de Desarrollo here, and he's using Telefonica data to understand, for example, how people move when there's a natural disaster, or how people move, for example, when they are during the summer, during the winter, etc. So there has been a lot of research in there. This is great, but the problem here is that you don't know the activity. You don't know what people is doing. So the next big thing is this one, which is what is called GPS data. And this is the data that these applications, location-based services, are using to provide you a service. So think about Uber, Lyft, or think about the weather application that you have on mobile phone. Or think about, for example, the restaurant recommendation. Think about Google Maps. All of those applications need your actual location at the GPS level in order to provide your service. They need you to geolocalize you in the city, right? So these applications collect this data, the GPS location, your GPS location, and they aggregate this data and they produce these amazing data sets that we consume, about 5% of the population, that we know exactly where people are to a resolution of 5 meters. So we can tell that you are in this room or you are having coffee in the next room. Okay? So that's the precision that we have. So the good thing about this is that we have exactly what activities people is doing. Because we can go and say, this is a Starbucks, so most likely people are having a coffee. Or something related to a coffee, okay? The bad thing about this is that it's only 5% of the people, because these location-based services are only consumed by a fraction of the people, but we have that, okay? And I'm not going to talk about Bluetooth. This was used for example, during the COVID time to do these digital tracing applications in which when two people get together and they have Bluetooth activated, your mobile phone registers that there's a Bluetooth nearby, okay? And this data was used during COVID to know how people were getting together and who was actually infecting whom, in using this digital that I'm going to talk today. So I'm going to talk about this one. This one because we know where people are, we can reconstruct the trajectories of people through the day, but we can also see where, what is the kind of activity that people is doing, all right? Every point that you're going to see here is a person that is staying in a place for more than 5 minutes. And the color indicates a proxy for income. So that's the project that we did about segregation. We wanted to understand where people of different incomes get together and where people of only one income get together. So places that were working more as a mixture of incomes and places we were working more for segregated places, okay? So you're gonna see the time of the day. This is a typical day in the Boston area. This is the city center, this is the Charles River, this is MIT, this is the airport. You can see even the gates at the airport in this data. And I can tell you, for example, which is the airline which is more segregated. What is the airline that is more segregated? We were talking about this today. Okay, so at the beginning of the day, you're going to see it started in midnight. So this is going to be midnight. At the beginning of the day, you can see that reds have with reds, obviously because you are staying home, blues with blues, etc. Then when the day starts, you can see that people of different incomes get together in the city center, at the universities. This is the hospital area. You can see even in the gates, people are getting together. So this is the kind of data that we have. That we can investigate the trajectories of people through the day, even at the gay level, for example, which is amazing. Okay? And here, for example, what is the role that the places in the city center, like for example, libraries or schools, etc., play in getting people of different incomes together. So this is the kind of data that we have. We have a lot of data. This data is massive and it's really complicated to work with. Let me show you what we got from this data, which is this behavioral box that was missing in relating urban environment to societal outcomes. Okay, but first of all, why we need large-scale data? Because most of the data you probably are collecting and you're using and you will use in your life is going to be small. Don't get me wrong. Small data is the best because you know a lot about this data. But large data is also good because it allows you to find other, let's say, large-scale patterns that help city design policies. Sometimes policies can be at the level of classroom. We were talking before about the classroom policies, and you need small data, small quality data. But if you want to talk about transportation in the city, you need large-scale data. Okay, it's the only way to address problems in transportation, for example. Okay, so why we need large-scale data? Okay, one thing is that we need, let's say, farther, faster. We need data that allow us to investigate things that are happening in real time. Also at the granular level, in this corner of the street and that one. This is great. This is actually why companies are so interested in this data. They are creating, let's say, urban digital twins at the level of a street, or at the level of the corner, or at the level of building, etc. So they can investigate how many people get, for example, into a Starbucks, or how many people get into my competition, so let's say, shops. This is great, but this is not the most important thing. For me, this is not the most important thing companies are doing. This is boring. Okay? For me, the most important thing about having this large scale data are the three things. The first one is the causal question. You are working with data that has or reflects behavior of people. And with you, the first thing that you do is to understand what is happening. Okay? You collect the data, you understand what is happening. In my classroom, I see that these people are talking to these people, and then, or for example, yesterday we were talking about, for example, in Twitter, this conversation is polarized into two groups. This is the what. It's very important, don't get me wrong, it's very important. But the most important thing is why. Why these people are talking to each other only. Or why, for example, in the classroom, this group of people is active. Understanding the why requires to design an experiment. You have to design an experiment. Okay? To understand, for example, what is the role that the shape of the classroom or the teacher plays in the relationship between students. You have then to design an experiment, which is, I split the class into two, or I take another class which is very similar to me, to this class, and then I run an experiment in which I put what the professor or the teacher in one room, and in another classroom I put another teacher. Or for example, the shape. Instead of having this elongated shape, I want to have a more horizontal shape. And then I have two teachers teaching in two classes which are different. That and why is actually why we need large-scale data, because we can understand and we can go and understand the causal question. Because everybody is running experiments every day. Think about yourself. You're running experiments your whole life. You're thinking, what will happen if I take the bike today? This is an experiment. Okay, we can see that you talk the bus every day, and then you take the bike, and then we can understand how, for example, what is the implication of the number of places that you go to. So in this large scale data, we have experience. The other one is that, most of you come from sociology, social changes are really hard. Changes, I mean, think about yourself. Thinking 1% of your time is changing half an hour of your week time. Just 1% is half an hour. So you think about it, I mean, you don't change from one day to the next one. You say, yeah, I'm going to take Mondays and I'm going to do completely different things. You don't do that, right? At most, you can change, for example, I don't know, going from yogurt to kefir, or going from, I don't know, yogurt to granola. I mean, this is the kind of changes that you want to do in your life. You don't want to change dramatically. So most of the social changes are small, so this is why we need large scale data. And the other one is, the real one, is because cities are not, are systems of systems. So you want to understand, for example, what is the effect of transportation. We also need to understand unemployment. We also need to understand health access. We also need to understand, for example, economy. So we need to understand the whole thing together, and the only way is using this large scale data. Okay. So let me just, so in our group, this is the vision that we have, is that the city is really a complex dynamical network in which there are many ways to represent this data, but in our mobility data, basically we have is a bipartite network. I know that you saw this morning or yesterday a bipartite network. We treat cities as a bipartite network in which we have individual and places. So the bipartite is very simple to define. This person visited this shopping place. These people also are going to this one goes to this one. So this is a bipartite network, and I'm going to show you that most of the problems that we are in city can be understood using this bipartite network. For example, we have work. What is the impact of urban environments in the consumption of fast food? Go to this bipartite network. See where is the people that are more visiting fast food, and understand what are the conditions, for example, of income, demographic, and even the place that they go, the exposure that they get to places in the consumption of fast food. We, for example, have a paper that showed that if you're exposed to 10% more fast food in your life, you consume 20% more fast food. So it's not linear, okay? Think about it. The choices that you make in your life, okay? For example, I can tell you that I changed jobs. Going from MIT to Northeastern is just crossing the river. But I went from a place that had a lot of fast food to a place that has relatively more fast food, and I can feel it in my waist. Anyway, but that's my personal life. So there's many things that you can do here. For example, you can investigate also from the point of view of companies. You can investigate what is the market of my business. What is the market? Where is these people coming from? And what is the effect of the competition, this place, on my team? So this is the bipartite network that can be used to investigate a lot of economic, a lot of health, and for example, and even, for example, lifestyles of people. Okay, you know the bipartite networks. And what do you do with a bipartite network? You can investigate the bipartite network like this, or you can project it, right? So let's project it on people. So the first thing, one of the things that we did, we have a lot of work about that, is that by going to the same place, these people have what we call mobility similarity. They go to the same places so they can get exposed. This is the network in which viruses spread. Okay? Because these two people go to the same coffee shop, and they closer, they don't have to interact. You're just basically waiting in the line for the coffee, and because you are close, and then you cough or sneeze, then you can get infected by other people. This is the one that we were using during the COVID. But also this network can also tell us what is the segregation that you experience in your life. Because if you go to places and you only meet people which are very similar to you, okay, if you go to this fancy coffee shop with baristas and in which the coffee is about 6,000 pesos. I went over to one of the places this morning. It was amazing, but 6,000 pesos. Then you're basically segregated. You are meeting people which are only similar to you. Okay. And we did a lot of work about segregation by investigating what is the homophily. I don't know if you have seen that already. What is the homophily in this network? And this is obtained from the mobility. By investigating what are the places that you go to, I can tell you what are the places people that you're exposed to. Okay, so this is the network. When we project it into people, this is the one. The other projection that you can do is places. You can project places, and you can see that this place is related to this place because they share clients. Okay, and then I'm going to talk later about this project. They share clients. So you can see, for example, that this place is competing with this place for people. Or not. They are symbiotic. With the sense, for example, you have an ice cream place next to a coffee place, they could be symbiotic, right? Or they could be competing. because they share or not places. Okay, so you can see that this network can tell us a lot about the city, and this is basically what we have been building. Using the mobility data, we see when people go to places, we project onto people, or we project to places. Okay, let me show you. I don't know what time is. Yeah, we have to finish. You didn't tell me that we have to finish. I'm going to move to the application. Let me show you just one application about the last projection. So this started actually with COVID. During COVID, there was a lot of articles saying that because people were not going downtown, because everybody was staying at home, some of the restaurants downtown were suffering. Because obviously, the people that went to the restaurants were the people that went to the office first. Okay? So you can see that this was this dependency between places that was driven by this people movement. And then we thought about the idea, okay, how we do this for every place in the city? How, for example, a park depends on the restaurants nearby. And the other way around, how the restaurants nearby depend on the park. So we wanted to build this network of how places depend on each other, with the intention of, for example, simulate economic shocks. What happens, for example, if we open a restaurant here? What happens if the restaurant closes down? For example, if you think about a coffee shop which is next to a restaurant, maybe the restaurant closes, the coffee shop is going to suffer. So this is what we did. We investigated how business in the city depend on each other. So we built this dependency network in which nodes are places, businesses or places, and the link is the dependency between them. Of course, the question is how you define dependency. And we did very simple thing. So for example, how the Starbucks, which is near MIT, depends on MIT. So we took the number of common visitors to MIT and Starbucks, and then the dependency on the Starbucks on MIT is the number of common visitors divided by the number of people that visit the Starbucks. So if all the people that visit Starbucks also comes to MIT, this is 1. If none of the people that visit the Starbucks comes from MIT, this is 0, all right? This is asymmetric. So you can see this is basically, we build this adjacency matrix. I depends on J. It's asymmetric. Of course, MIT does not depend on the Starbucks, because the amount of people that comes to MIT is huge. Okay? So the number of common visitors to MIT and Starbucks is a very small number compared to the number of people that comes to MIT. Okay? So this is how we build this dependency network. Again, every node is a business or a place, and the link is this dependency between them. Okay? Okay, so if you talk to an urban planner, they will tell you, no, if you build it, they will come. This is the sentence that they typically say. If you build it, they will come. If you place something next to another place, they will come. So for example, this is a typical white paper that they release when they have a transportation policy. If I open a subway station, the business around are going to benefit from that. Right? This is the typical thing. If I develop, for example, new houses here, everybody's going to benefit. The businesses there around is going to benefit from that. So that is using distance as the only reasoning for human behavior in cities. And this is what you get. Basically what you get, this is the Boston area, so sorry you don't know Boston. Basically, again, this is the city center, this is the river, and then you have Harvard here, you have MIT, and then etc. So if you use distance only, what you end up seeing is that places depend on each other. You don't see the nodes here, sorry, because it's so messy. And remove the nodes, you only have the links. And they are very, very, let's say the intensity of the links is very small. So you only see where the concentration of links happens most. So what you see when you use just distance, like if I'm near to this business, I'm depending on that business, is that you end up having these shopping districts. So you have the city center cluster, you have a cluster in the medical school, you have a cluster in the museums, you have a cluster in the Harvard Square, etc. I'm going to show you next what we found in the data. This is what we found. So the first thing that you find is that there are these long distance dependencies in the city. Okay? So you can see that some of the places depend on places which are really far away. Why? Very, very easy to understand. Commuting. People commute every day in the United States about 30 miles, which is about 45 to 50 kilometers. It's huge. In the United States, people commute a lot. Okay? I don't know, in Santiago probably the same, right? Because it's a big city. So that means that the gas station, which is in the route to downtown, depends on the offices downtown. If the offices close down, the gas station is going to suffer a lot. Okay? And the coffee shop, which is nearby the gas station, is going to, and the donut place is going to suffer too. And the small bookshops there is going to also suffer. So you have these long-range dependencies that comes from people here. The other one is that you have less local clustering that you will get here. So this idea that if you put your coffee shop next to a very fancy restaurant, immediately you're gonna get great clients, it's not happening. You can see, for example, that some people go to a restaurant and then they go home. They don't visit the store nearby. They don't visit everything nearby. So that's actually not what you expect, and it's actually entangled with the human behavior. Okay, so the most interesting part that we did in this paper is the following: is that now everything is connected to everything in the city. So if you have, for example, a new train station, this is going to affect the coffee shop. Okay. So you have more people coming to the train station, yeah, more people coming to the coffee shop because this coffee shop depends on the train station. But also, there is a retail shop which this coffee shop depends on. So if there's an increase in the number of visits to the train station, maybe there's an increase of visits to this retail shop, and then an increase to the library or to the, let's say, the city hall, an increase to the library. So this library, which was really far away in the city, is going to be benefiting from having a new train station into the parts of the city. Because people that typically go to this library commute to this place using this train station. All right? So this is what we did, and well, this is the math. But anyway, I'm going to show you that it works. We can predict much better what is going to be the decrease in the number of visits during COVID using the pre-COVID, let's say, dependency networks. So by knowing how business depend on each other, we did a simulation, and we found that we could predict the decrease in the number of visits to businesses using this dependency network. Okay. All right. And I promised to finish at 1 or 1 or 2. The other thing that you can do is to do simulations. For example, with these simulations, like I was telling you, having this urban digital twin, you can investigate what will happen. For example, in one of the nodes in the network, decreases their visitation patterns by 50%. So for example, what will happen if people decrease visits to colleges by 50%? This is not something which is unreal. It could happen, and actually, we have a government that is working on that. But here you see, for example, what is the businesses which will be affected by the decrease in the number of visits to colleges in the Boston areas. And of course, you can see the blue points here are the college, places, and the red reddish points are other places. So you can see that most of the places which are affected are nearby the colleges, but you also can find that places which are really far away from colleges can be affected and those, for example, are typically museums, are entertainment places, coffee shops are really affected by this decrease. All right. If you want, you can play actually with this data. We have a platform, and you can see what is the network, and I just bring it because it's a very nice visualization of the network in Boston. You can select the places, you can investigate which places depend on each other, etc. All right. So thank you so much for inviting me again. Thank you so much for allowing me to share today what we are doing. Of course, this is not my work. There's a number of people that were involved in this, and I have all the references about our work. And also, if you want to understand a little bit about sparse and urban networks, I recommend these 4 papers that tells a little bit about why sparse networks are different and how we need. It's not that we can. No, we need to use networks to understand cities. Thank you so much.
Any questions? Thank you, Sam, for the interesting talk. We have 30 minutes until 1:30 for questions. So
Yeah,
please,
okay, go ahead.
And thank you, Sam, for your excellent presentation. I was thinking about these city networks, and you said that a route cannot have 10 courses. I don't know. And how do you deal with these highly connected nodes? Because you treat it like an outlier and just cut it. Because if you cut a highly connected node, the network suffers, right? How do you deal with that?
So it depends on obviously the network. For example, in transportation networks, you don't have typically a highly connected node. Even train stations, for example, in the subway, in the city center, at most they are connected to other 4 lines, or to other 5 lines. It's impossible that you connect a line to the other 10 lines, so it's impossible. Physically, you don't have space underneath the buildings to build that. So we don't have, in transportation networks and in road networks, we don't have typically nodes which are highly connected. Okay, this is one thing. Think about also electricity. You don't have nodes which are highly connected, for example, or water. like a water sewage, let's say, system is not, you don't have a station that is connected to thousands of pipes, okay? You don't have. But there are other networks which can be highly connected. For example, in the places that I was showing you, there are places that we know that they're highly connected. They are not super highly connected, but they are highly connected. For example, think about event spaces. Like you go, for example, to a sports, let's say a game or a match, and then you have all these restaurants around it. You have also the transportation hubs around it. These are very highly connected to those places. And this is not a bug, it's actually a feature. So you want to understand why these places are highly connected to the places. And the reason is very simple, is because there's a lot of people going to those places. Okay? So I wouldn't say that these are outlier per se. An outlier means that there is some statistical error or a statistical, or that our model does not describe statistically that data. Is that we in our let's say analysis, those outliers have a meaning in the city. They play a role in the city. So we don't have to discard them. So we have to include them. Some analysis might depend more on that places. Some analysis, for example, might depend less. For example, think about social connections. I want to investigate what is the role that places play in creating social connections. Right? This is a very famous, let's say, I don't know if you have read the book by Putnam about third places, why people are bowling alone. I don't know if you know this book. It's amazing. It's about the role that places play in creating social relationships and maintaining them. And Putnam's thesis is that there are less and less places, these third places, which is not your home and work, these third places are actually, they were very important at the beginning of the 20th century and the second part of the second century, but it's not anymore. So people don't go to coffee shops, for example. In the United States, it's really depressing. You go to a coffee shop and nobody's talking to you. And you're just like, oh, laptop. So in my home country, South Africa, that would be, you will be kicked out if you open your laptop in a coffee shop. Anyway, and I've seen, for example, the same thing here. People are very social. You go with a friend to a coffee shop rather than just Anyway, so if you're thinking about social relationships, for example, and which places are creating social relationships, you don't want to include stadiums. You don't want to include soccer stadiums or for example, or basketball centers, etc. Because people go there, watch the game, and they move out. You don't get, even if you are sitting next to someone during the soccer game, you probably don't talk to them. Okay? So those places are really outliers for the problem that you're investigating. But they are not outliers, for example, for virus transmission, because you're in contact with a lot of people there. Okay? I don't know. Hope I answered your question. Yes, Alejandro.
Well, thank you very much for the presentation. It was really fascinating and I really like the work. I think I was also very impressed in what I listened to. You really like it, very nice. I just have a very pragmatic question. Well, I will go for the second question. When you are now analyzing this data about the dependency between the groups, I got the question, let's say there's backgrounds somewhere. So my question is, would you be able to say whether the bankruptcy could be because of the connections, because it was a bad business that had something that interested you, have you ever tried to figure out what was going on there? Because I think it would be a really interesting study with the type of data that you have.
Okay, because this is recorded, I can only answer one thing, but for research of the camera, I can answer another thing. Because we did a lot, in the past, we did a work with a company that was using this data especially for predicting commercial credit risk. So you know that when you open a shop or you open a store, you typically open a line of credit with the bank, so you can get money to start. And the bank is really interested in whether you're going to succeed. So the reasons why business is successful, there are many of them. And one is the market that you are placing your business and how your business is going to depend on the other. So what I can say is that this is part of the equation, but it's not a complete equation of why business is. So for example, during COVID, we found that yes, we could predict much better the decrease in the number of visits to a place by using how they are interconnected, but we couldn't predict the whole one. The variance that we could predict is about 0.5%, which means that there's 50% of the variance, which is explained by other companies. It could be, that, for example, that the owner, decided to close the business because he's about to get retired, or any other thing. Like, for example, the business was making bad decisions before COVID, and then COVID just basically pushed them over the fence, and the next goes. But what I can say is that this is part of the equation. Okay. More questions?
Something maybe simple. I don't know if I know this, but can you say something about the access to this data? Because I imagine that it's not.
Well, during the COVID, it was public. There was a number of companies that decided to open the data because of the interest and the social interest of the data. So during the COVID, there was a lot of telco companies, for example. I know that Telefonica, for example, here decided to open the data to researchers. They aggregate data, the flows of people between communities and municipalities in Chile. And during these special times, it was public. I know that also the National Institute of Statistics, I don't know about the Chilean one, but in the Europe, they are collaborating with the telco companies to get this data for particular uses. Like, for example, tourism. This is very important because most of the countries, they have a very good census about where people, Chileans, for example, about where people in Chile that are nationals, citizens in Chile, live, work, etc. But what about tourists? You don't know. You know, because they come only for 1 week. So, for example, they are using this data for. They're using this data, for example, also to build what is called the mobility surveys, which is this very useful data sets for cities. This what I was calling the origin destination matrices that are built through the movements of people every day that go and how many people go. This is very important for transportation in the cities, for designing policies, for design, for even managing resources, etc. Okay, but there is also a whole market out there of this data for private companies. You can buy this data. This data is not inexpensive. It's not super expensive, but it's not inexpensive. And I can tell you, we buy this data. We buy this data for we have an agreement with the company that we because we are only doing research on this data, we have a special price. So there's like a different tiers depending on what is your application. There are many companies I can put in contact if you want with many companies. I even, for example, with Leo Ferrez that has this data here in Chile, and they use it for many different purposes. But we benefit somehow that there is a huge interest of this data for the commercial side. So there is a whole ecosystem of data vendors, data dashboard, let's say, kind of companies, and also companies that process this data, collect this data, and sell this data. Okay, and we benefit as our researchers from that. So we don't collect this data. Can you imagine? I cannot collect the mobility of, for example, in Boston area, we have around 200,000 people. I cannot design an experiment to do that. Although we are working in more what we call data collectives. Like if there is a community which is interested in understanding what's happening in the community, maybe as a community you can start collecting this data. And you can promote that the people living in this community donate the data for a specific use, for a specific purpose. We are working also on that, but that is hard because this data has a lot of privacy concerns. None of the questions so far was about privacy. I have another 100 transparencies about the privacy part. But this data you have to really, really be careful because it contains a lot of has a lot of privacy concerns. But you're interested, I can tell you the price tag or the price level that you want to pay. It's about the 10,000s per year. Dollars. No Chileans. More questions?
More questions.
Yeah, sorry. Sorry, what?
When you with this data, you can identify what is the type of vehicle.
Yeah, you can do that.
And separated that the mobility is by bicycle, by walk, by car.
You can do that. This is what Google does. If you have Google, they tell you that you are on a car, and they tell you that you are biking or you are walking. And what the Google does is they store your location, the GPS location. These are points. They build the trajectory. They estimate your speed. They map what is called match your trajectory to the map. They match the trajectory to the map. They investigate whether you have a probability that you're taking the bus or taking the bike or walking. In the city, I can tell you that those algorithms work very well, but there are areas, for example, in the city center, in which sometimes it's really difficult, like distinguishing between being on a bus or being walking, because the bus goes so slowly or the car goes so slowly that and also, for example, there are other places like the subway, which are different. But you can do it. I didn't talk about this today because for me, the only thing interesting was people and places. So people are doing activities in places. But there's also the trips from place to place, which are also very, very useful. Pablo.
Well, I wanted to go.
All right.
But anybody else? So I was curious. So you focus on Boston and LA. How big an issue is the boundary problem? Because obviously there are going to be people commuting from pretty far outside of Boston as well. Do you think that affects analysis and review for?
Okay. Well, we're talking about what's called in geography. It's called the modifiable area unit problem. MEMAUP. It means that what is a city? The people the politicians, they know very well the administrative boundary of the city, but people don't organize their life across administrative boundaries. Okay, well, you pay taxes probably within an administrative boundary, but you move around. I don't know Santiago, but probably you move around many communities. So this is what is called the modifiable area unit problem in geography. That if you investigate things at the level of administrative boundaries, you take one result, and if you go to, for example, the metro area, you take another result. Okay, so that's crucial. You have to define what is your city. In our case, we took instead of doing our own definition of the city, which we can do. I will tell you a little bit later on this. What we did was to use what the people that have been thinking about this place use in the census. The census is the Census Bureau. Is this statistical office in the United States that have this is amazing. The census in the United States is amazing. And it's very well organized, and very kind of data. And they end up with what is called metropolitan areas. So metropolitan areas are collections of counties which are related by economic, social, and transportation links. So think about if you think about it, it's like you do the mobility network. So every point is, let's say, a census area, and the links are the number of people moving from one to another. Okay. Basically, what they did was to do community analysis on that network. So they found the communities where people mostly live and move around, and those are what is called the metropolitan areas. It's not perfect, but it's the best thing that you can get because these are the most connected areas. That means that you saw this morning communities, right? Communities are defined as a cluster of nodes in which most of the links are within that network, within that cluster, and then links from this cluster to another one are minimum, or less frequent than clusters be. So that's the thing that the census uses. Those metropolitan areas are clusters of zip codes or counties, in which most of the mobility happens within them. Okay. So this is why when I was talking about social networks, this one, this is the metropolitan area of Boston. Boston is this only. This is the city of Boston. And this is the metro area that we are using. Okay? Because people from New Hampshire are going to Boston. Yeah.
Actually, does it have to have another question about this particular? So these are connections only between the postal codes, right? Not within.
Yeah.
Okay. So
I also have the thing.
Yeah. So but I was thinking, could this be an artifact of like Boston proper, for example, being a walkable, which means that the actual distance matters a lot more in terms of relation?
Could be, yeah, could be. Actually, that's a very good one. Actually, we have not us, but not only us, but all people have found that the relationship of links in the city center is different from the rural areas, and the reason is because in rural areas there are less places that you can go to. Okay, so everybody knows each other. I don't know if I come from a very small place, as Alejandro was saying, Salamanca, everybody knows everybody. Okay, so it's really like this close close communities in which there's a lot of relationships.
But it feels like this one kind of hides a lot by just not showing within postal code.
Yeah, I can show you everything, but in the city center is because you have more probability to know people from other places because you have many places you can go in Boston. But in the rural areas or in these very urban areas, everybody knows everybody. So basically, there's more chances that people in the city can see customers. And distance matters a lot, much more in these areas than in the cities. All right, more questions? Yeah, go ahead, Father.
If there's absolutely nobody who has initially. Okay, I'm curious how. Now some places like have different amount of things dependence on cars on driving, right? And so I would expect LA to have more than Boston, but then Boston more so than New York City, for example, and in fact New York City probably more so than some European cities. So how the mobility network differs from the spatial network? Does that discrepancy vary based on car dependence?
Yeah, this is my whole point, that the urban environment modifies your behavior, and the behavior modifies your. So the good thing about, one of the things that we found in the United States is that there are cities that have no public transportation whatsoever, and it's minimal, the public transportation. You can go to cities like Dallas, in which the public transportation is really bad. You can go to places like Boston, in which the transportation, for let's say for European standards, public transportation is really bad, but it's much better than Dallas. Okay, so you can have this variety of different public transportations, and you can find that, for example, social connections are different in different cities. Even, for example, the thing that I was talking about, spatial segregation. I mean, how people of different countries together is different in Dallas than in, for example, in Boston. So yeah, it plays a role. But it's well known that public infrastructure and public transportation plays a role in creating connections, opportunities, even, for example, accessibility to groceries. It creates all these problems, and this is really well known. And of course, you're right. I mean, that's what happens here in the United States. The other thing is about, and I always have this question is, okay, most of the things that you told were about the US. But here in Santiago, we are different. So we are totally different. That's not true, anyway. Because most of the big cities have the same big problems, for example, transportation, commuting, access to jobs. Jobs are not equally distributed in big cities, right? So you have to commute to University of Montevideo, which is where most of our jobs are, or you have to go to the downtown. Anyway, but that's true that in other cultures, mobility is totally different. For example, commuting is not as prevalent in other countries, like, for example, in the United States. Access to car is more prevalent or more usual in the United States. Everybody has a car than in other countries in which we're talking about, for example, we did an analysis of Mexico City. And in Mexico City, you have pockets of Mexico in which nobody has access to a car, or only a small fraction of the community has access to a car. Public transportation is really terrible. Like going from one of these pockets to downtown takes you 2 hours by public transportation, and it's very expensive for the income of these people. So these people are trapped. So when you talk about commuting 30 miles, they say, no, I cannot do that. I mean, physically and economically and even family-wise, I cannot do that. So there are places in which the access to mobility is so difficult that these results are going to change so dramatically in those countries. But for the rest of the city, of Mexico, which people have access to their car, I mean, I can see that these patterns that we see are actually repeating from one country to another. They are repeating. We also have a study in India, and something coming out of India, and this is our program, especially in big cities. We're talking about big cities. If you, even in the United States, you go to the rural areas, this is what I mean. No questions.
Something to take to the city council, I suppose.
Eh?
Something to take to the city council.
Yeah. We're actually working with the city of Boston in transportation. What is the role that transportation plays in what people do before and after getting on the bus? Because this data can tell me what people did before getting on the bus, and what people do after going to the bus. So transportation policies is not that you get more people on the bus, it's that people do more things. They have more accessibility, they have more opportunities, right? So this is what we're investigating with them. All right, any more questions? Okay, I hope I have convinced you that now, when you go back home, you start thinking about all these networks which are around you. The people that you are encountering, this is the virus network. The people that you shake hands with, I don't know, in a new place, this is the interaction network. And how these businesses that you see are competing with each other or not. All right? Thank you so much. Thank you.